All right, so we're not going to do a lot of practice or lab work over this, but I did want you to see a little bit of the lattice package within R. It's one of the more important graphics programs, along with ggplot2, that you'll need to learn. So I'm just going to go over the code rather than having some slides associated with it, because you really just need to run through the code to understand the structure and syntax and what it can do for you. Okay, so here I'm going to simply enter some toy data. Okay, here we have a randomly generated X and Y, we have their sex, we have the treatment randomly generated as well. So we're going to plot a very basic scatter plot that has these trellis elements. And look at the formula used in the function call. We're saying y is a function of x, and that will depend on the sex. So we should have a plot for male and a plot for female when we do this. Let's find our graphics window. It's hiding. And sure enough, we have a plot for male and female. Now notice, because this is not actually related, there's just a scattering of points. Now I could go and I could add a little bit of noise. Oh, I meant to do a plus there. And now we see something that just doesn't look like a cloud of points, but we can see a linear relationship. I could add in the gender element as well and make it maybe distinct for males versus females. Okay, so we can do a little bit more with this trellis scatter plot. So notice again, I'm using the same base formula, adding some labels, doing a little bit of just cleanup and emphasizing the points in there. So this increases the point size. This makes it blue, the color blue. This makes the point character type a different shape other than the open circle. We're going to create a label, and then we're going to add an element here. So let's take a look and see what's different. So notice here we have different points a little bit more emphasized. We have in this shading here, and this just makes it a little fancier, maybe more appropriate for a publication. What if we wanted to include a grouping variable within each panel and add a legend as well? Well, you can do that. Again, the same base formula as we had before, but now we have a grouping variable treatment, and that's the main thing besides some fancy formatting functions that's changed here. So now what's the role of our grouping variable? Well, everything looks the same as it did before, but now we see treatment 1 is coded as a blue dot and treatment 2 is coded as a red open rectangle or square. So we can now look to see if there are any patterns associated with treatment as well as gender, or maybe it varies by gender for treatment. Okay, so finally we're going to use the panel points, which is actually a base function that is for plot functions. Let me fix this. To change how things are laid out. So this is kind of a long segment of code, but notice the base stuff is the same. And now we have, rather than the vertical arrangement of the panels, we have horizontal arrangement of the panels. We also have, you can see the females are all this rosy pink and the males are the blue, and we can still see the difference between treatment 1 and treatment 2. So same basic plot, no big difference here. It's just that now we have tweaked the design a bit. So another set of functions that I do like to use is the BW plot. This actually does a box plot, but it allows for trellising. So again, some toy data, and let's look at the basic plot. If you notice in the toy data, we have treatments 1 to 4, and then we have an age variable that we've actually cut into brackets, as is so often done, and then we have a kind of a mock response variable y. So here we might just want to first look at, is y a function of treatment? And so we could create a basic box plot, side-by-side box plot to do that. And because we did not generate y to be a function of treatment, we don't see a lot going on here. We just see kind of a side-by-side box plot that looks mostly random. But we can do a lot more than that. We could look at, is y a function of age that then depends on treatment? And so we can trellis this a little bit more. So if we run that segment of code, what happened? Well, we have the 4 treatments, but then we see it cut according to age. So we can see, for example, maybe with treatment 1, the response increased by age, and treatment 2, it decreased by age. But we might see these treatment-specific effects having to do with the relationship of age and the response variable y. So remember, notice the syntax. Age is what appears on the x-axis for each of these trellised plots. So that appears on the right-hand side of the tilde. And then our conditioning variable is treatment. Okay, so that gave you a little taste of some of the graphics you can do. We'll also look at ggplot.